Example 4 is a little different. We're working with a square root function to find a simplified form of the difference quotient. We were finding simplified form of the difference quotient for quadratic functions, one rational example, and mostly quadratic, right? But this is a square root, and I'm going to show you a cool trick to simplify this difference quotient. Let's start with writing down the formula for this. F of x plus h minus f of x all divided by h. Let me substitute x plus h into this function. So I will have the numerator start with the gigantic square root. Instead of 2x minus 1, I'm going to have 2 times x plus, yeah, I just want to copy it. Okay, x plus h minus 1, right? So that's what f of x plus h is. And I'll write down minus f of x, minus f of x. And f of x is that other square root expression, 2x minus 1. All right, all over h. Let me get rid of this purple highlight because I want to talk about the next part. Get rid of these purple highlights. All good. All right. Let me give you a little rule here. A minus b times a plus b. When you multiply this, you get a squared minus b squared, right? You can check it by foiling. We can do that real quick. That's a squared plus ab minus ab, and lastly minus b squared. So these middle terms cancel out, leaving us only with a squared minus b squared. Now, why does it matter in this problem? It's because, hold on, let me get rid of these. The goal, okay, the goal of these difference quotient problem in section 1.3 is for us to be able to simplify difference quotient to evaluate the limit of this difference quotient as h goes to 0. Okay, that's what we will be doing next week. In section 1.4, we're going to say limit as h approaches 0 of this difference quotient. But what will be the problem if I do that? I'm going to end up getting 0 in the bottom of the fraction, and that's not fine. That's not good. That's undefined in math. So what we're going to do here is it's a little different, okay? We're going to multiply both the numerator and the denominator by the conjugate of what we have up here, okay? So I'll write over it. Take a look. Think of this first square root as a. Then what you're looking at is a minus b, okay? I'm gonna try to do this. So I want to multiply a minus b times a plus b. So on what I'm multiplying on the other side, or to both numerator and the denominator, is going to be, hold on, I just know that this is going to be a long work. Exactly the same as what I have up here. Okay, but it's exactly the same as what I have up here. But the sign in the middle, instead of the minus, is going to be plus. Okay? And if I'm multiplying that to the numerator, I need to multiply the same exact thing to the denominator, right? Because anything over itself is 1. So by multiplying something by 1, I'm not really changing its value. I'm just making it look different, right? So now, let's use that pattern. Think of this as a minus b times a plus b. That's going to give us a squared minus b squared, right? And what this squaring will do is it's going to get rid of the square root. So our radicands will just come out of these square roots, leaving us with 2 times x plus h minus 1. The first radicand came out. This one came out because it was going to get squared. So I didn't want to write down square root of something squared because they are going to cancel out anyways, right? And then I need the minus sign. And I need to do b squared. So the radicand for the second part will just come out. This will just come out of the square root. But since that's a binomial, let me write this in a parenthesis. Why? Because I will have to distribute this negative sign and make the second one, this minus one, into a positive one, right? All right, let's look at the denominator. The denominator, we can't really do much. It's going to be h times this whole thing, all right? So I'll write that down. That's going to be h times square root of, oh, sorry, I have to write the, actually, no, this is good. 2 first, x plus h minus 1, but both are under square root. And then I need the plus sign, square root of 2x minus 1. Okay. Alright, I'm gonna get the numerator all simplified first, okay? If I distribute the 2, I will get 2x plus 2h minus 1. And by distributing that negative sign, I'll get minus 2x plus 1. And that is all over that nasty looking denominator of this. I'll just copy it down. All right, let's cancel some stuff out on the numerator. What will cancel out? Positive 2x and negative 2x cancels out. They're opposite. And I see the negative 1 and positive 1 will cancel out. Now look, the only thing left on top of the fraction is 2h. But notice what we have in the bottom. We also have h. So we're looking at h divided by h. So we can go ahead and cancel out this h with this h. So those are gone. I'll just go ahead and cross these out. Leaving us with, alright, I will have to make this a little bit smaller to fit more work, okay? Hold on. I'll make everything smaller. That's perfect. The only thing left on top is 2. And the denominator is just going to be that part, because the h got canceled out. So believe or not, that is the simplified form of difference quotient. Because even if you plug in h equals 0 here, even if I plug in h equals 0 here, the denominator will not be 0, okay? Denominator will not be 0. So that is what you can do to simplify a difference quotient for a square root function, okay?